here we have a definite integral involving or requiring a substitution. Remember, if you see a function in some version of its derivative, you can use substitution. So what I would do is I would let u equal 1 plus 8x squared, and then du becomes 16x dx, and you could replace x dx with du over 16, and then of course we have this becoming a u. Now the only other thing to do is to update the limits of integrations, because remember this is as x goes from 0 to 1. So when according to this relationship, x equaling 0 means that u is equal to 1, and x equaling 1 means that u is 9. And so my new integral becomes the integral from 1 to 9. X dx gets replaced with du over 16, and then it's the square root of u. And now I can just proceed as if this was the original problem. We want to think of this as u to the 1/2 to take its antiderivative, which would be 2/3 u to the 3/2. So 2/3 u to the 3/2. Evaluated from 1 to 9. You can also, at this point, I usually like to, that you can make this an eighth. So I get 1 over 24. And then u to the 2/3 would be evaluating at 9, 9 to the 3/2, sorry, 3/2 rather, minus 1 to the 3/2. And so this is 1 over 24. So then 9 to the 3/2 is the square root of 9, which is 3. 3 cubed is 27, minus 1. So it looks like we're getting 26 over 24, or 13 over 12, which is B.